Welcome back to another instalment of New Zealand's Bird of the Week, where in this video I will be talking about the Haast eagle, massive eagles that were the apex predators of New Zealand before the arrival of humans. I hope you enjoy. Haast eagles were first described by Julius von Haast in 1871 from remains discovered by the Canterbury Museum taxidermist Frederick Fuller in a former marsh after it had been drained, with Haast naming the remains Arpeggisynth Maori, after George Moore, the owner of the Glenmark estate where the bones had been found. The genus name was derived from the Greek harpax meaning grappling hook, and ornis being bird, although, as we'll get into, this position as a new genus would be called into question at a later date. The bones consisted of a femur, a rib and 2 claws, which was not much to go on when describing a new species, and Haast actually went on to break tradition in describing the bones himself. Important new material was usually sent to England for examination and description by some of the predominant authorities on anatomy, like Sir Richard Owen. Haast, however, pointed out that he did not want to take the chance of sending the valuable specimen on a long voyage to England, as other irreplaceable items had also been lost out at sea, such as the only specimen of a huge New Zealand moth and several fossil reptiles without a trace. He later sent plaster casts of eagle bones to Owen, but ironically, Owen did have access to a bone of an eagle for nearly 20 years before the Glenmark find, although he didn't know it. More bones would later be found in 1873, with many coming from a smaller individual, with the cautious Haast noting that they probably came from the male of the species, as male birds of prey are often much smaller, but instead he described them as a new species. Arpeggisynth similis, as being a naturalist in the Antipodes, wanted to further his reputation amongst the distinguished names of Europe, and naming 2 species of huge eagle was better than naming 1 in his eyes, even if it was flawed to him. Haast noticed similarities to harriers and falcons, and later other experts thought that they were closely related to either sea eagles or the golden eagle group, although we'll get into that soon enough. Further specimens would later be found that indicated Haast eagles ranged across the South Island, but interestingly, remains coming from the nearby North Island have been controversial. Paleontologist Trevor Worthy, a person well known for his work on Australasian avifauna, stated that several of the reported occurrences in the North Island did not stand up to scrutiny, finding that bones were based on sheep, pelican, and an extinct subspecies of black swan than to any eagle. A more persistent record was that of Augustus Hamilton in the late Pleistocene site of Te Aute in Hawke's Bay, although this was later resolved in that the description had misidentified the bones as those of the Isles harrier, another large raptor that the describer did not know about. Only one other bone remained where the origins were less clear, being a bone collected in southern Taranaki dating to around 6,000 to 5,000 years ago, by the son of Gideon Mantell, Walter Mantell. Where the idea that this was an eagle bone falls apart, however, is that Mantell also collected at other sites, including one at Waikawaiti in the southeastern South Island, where bones pertaining to eagles were definitely known of, in the absence of other remains from the abundant deposits of Holocene age in the North Island. It is therefore likely that the bone was misplaced in collections on its way to England, instead of being a natural occurrence. Because of this, and that no analogous fossil sites to those in the South Island, which have presented incredible fossil material, have found such bones, Haast eagles were therefore confined to the South Island despite the narrow water gap and abundant prey up north, which to this day largely remains unsolved. Bones in the South Island continue to be found despite this, and the 1890s in particular produced a new series of eagle finds. One rich site was at Castle Rocks in Western Southland, where excavations yielded the remains of 2 individuals, being a male and a female, with the latter being one of the largest specimens ever found. After this, there was a lull in the report of findings, as most of the large swamps had been drained, and cave exploration had not yet begun in a large enough way. It is therefore something of a puzzle and an indication to the mystique of these great birds that they were still considered one of the rarest of finds well into the 1980s. Since 1985, finds of eagle bones have become more frequent as cave systems in the South Island have become better known and understood, and the importance of old lake sediments and rock shelters was realised. Haast eagles are now represented by copious material from over 40 sites, with more than 60 individuals being noted, although only one 99% intact skeleton is known of, as we'll get into. The range of sites has also increased, but almost all are within the known boundaries of the eastern and southern South Island. with all the remains found in northwest Nelson except for one, and a single record on the west coast. All have been from sites of the late Otterang Glaciation age, from between 20 and 14,000 years ago, with an exception being the spectacular discovery of a 99% complete skeleton of a large female 1,500 metres near the top of Mount Owen in Nelson. This find is notable for many reasons, as the find helped to resolve years' worth of issues regarding the allocation of bones among individuals. As before, it was hard to tell if fragmentary bones belonged to differing individuals in deposits where remains hundreds and even thousands of years apart could be found near each other, which in the case of this specimen there were no duplicate bones, and the characteristics and small size of the site makes it certain that this was just one animal. The only missing elements are most of the scleral ossicles, a caudal element from one side of the hyoid, the second phalanx of the major digits of the left wing, and the accessory bone at the carpal flexure, making it possibly the most complete fossil and or subfossil skeleton of an extinct bird of prey ever found. Most of the bones were found in excellent condition given the dry conditions of the cave, and almost all were in the position where the eagle had died and decomposed, its limbs distorting as the muscles and tendons contracted. The pelvis was at first missing, although it was later found in a second chamber, where it seems to have been taken by a weka whose bones were also recovered from the cave. How the bones ended up in the cave is also interesting, as from the nature of the cave and its entrance, it is likely that the eagle was standing on the ridge of the cave, overlooking two mountain basins where populations of upland and crested moa would have been present. The eagle then probably fell into the hole accidentally, perhaps breaking through a snow crust that obscured the entrance, or hearing a prey item that has fallen in. Once in, the sinkhole entrance being about 1 metre in diameter and leading to a vertical shaft about 15 metres deep meant that due to their wide wingspan and inability to effectively fly up, the eagle eventually succumbed to starvation and perished. A fibula from the eagle was dated to around 2,160 years old, so much of the landscape traversed by climbers was very similar to what this bird last saw before its demise. After being discovered and being known to science since 1871, it had been a source of much intrigue to many interested in New Zealand fauna and paleontology, although, until rather recently, virtually nothing was known of how they lived and why, or how they were related to other kinds of eagles. This segment of the video will cover their evolutionary history and taxonomy, which will come in handy when discussing their anatomy, behaviour, habitats, and potentially their coloration. For some time, they were thought to be related to either the forest eagles of Africa, the wedge-tailed eagles of Australia, or some form of sea eagle, with all being comparable in size to the Haast eagle. This made sense for a long time until genetic evidence, as it often does, completely changed this view, and that these massive eagles, the largest known, had quite the humble beginnings. DNA analysis found that the eagles were most closely related to the much smaller little eagle of Australia, having diverged from these smaller birds as recently as 1.8 million to 700,000 years ago. The evidence for this comes in the form of genetic studies, but also osteometry and high-resolution tomography of skeletal remains that were used to determine morphological and significant characteristics of the peripheral nervous system to understand their evolution based on molecular and external morphology. Interestingly, compared with other related predatory birds like other eagles, hawks and old world vultures, these eagles had a proportionally low endocranial volume for their body weight. There was no anatomical evidence to imply the significant use of olfaction by Haast eagles, as the olfactory bulb size was no larger than would be expected for a bird of their size, and as they had a poor sense of smell, something that we'll get into, it impacted their prey and continues to do so to this day. The analysis also found that the species had a relatively small brachial enlargement for their body size, being supported by the small size of the neural canal, and being most comparable to soaring birds like gliding falconiforms or condors, rather than small forest eagles. The authors therefore concluded that this was proof that Haast eagles had evolved from smaller ancestors at a rapid pace at the expense of the enlargement of the brain and visual, olfactory and vestibular uses, and that they may have had poor developments of fine motor control for their wings to be able to allow them to swerve between the vegetation in dense forest. They also stated that they were therefore best adapted for hunting prey in open terrain, either by swooping from mounting perches or large isolated trees, which will also be discussed later at a more relevant point to bring this all together. Such a size increase is notable, as in such a short period of evolutionary time, the ancestors of these eagles, likely a population of little eagles, increased in size by 10 to 15 times, one of the largest and fastest increases in average weights of any known vertebrate species. From looking at the evidence, birds would have been able to colonise New Zealand through a westerly wind current over the Tasman Sea, which has managed to allow birds like silvereyes and swallows to both reach, but become established in New Zealand, and this would have also included little eagles. Both of the Australian relatives of New Zealand's giant raptors are species of open woodlands and grasslands, with New Zealand being densely forested for millions of years. It meant it was therefore harder for these animals to establish populations, even if they could make the journey. However, the expansion of open woodlands and grasslands near the onset of the Pleistocene glaciations, which is also consistent with the time estimated between the divergence of Haast eagles, it provided a window for these open land-adapted migrants to establish in New Zealand, from which they could then further adapt to any changes. In contrast, no case of New Zealand endemic or native bird species reaching Australia has been known from the same time period, likely due to the westerly winds over the Tasman, hence why there are very few, if any, birds descended from New Zealand stock in Australia. Once in this new land, birds face very little competition with the lack of mammalian predators, as well as from other birds of prey like owls and harriers, and were therefore able to exploit this vacancy to become far larger in a short space of time, to take down the readily available and much larger moa, which over the course of natural selection favoured birds that were larger and therefore more likely to succeed in bringing down larger prey. In this regard, the Philippine eagle is an appropriate living species to compare with, as it too evolved in an insular environment from smaller ancestors to island gigantism, in the absence of large carnivorous mammals and other competing predators, although they did not surge as heavily due to their prey being generally smaller than themselves. It was found that they were actually closely related to basal snake eagles, which is another comparison as to how these massive eagles arose. Because of their new classification, the genus name of Arpeggisynth, having been well established for over a century, was called into question given their taxonomy, and were therefore reclassified as Hieratus mori. However, both the little eagle and other closely related booted eagle are sometimes reclassified under the Aquila genus, and some have even stated that it should remain in its own genus of Arpeggisynth, although Hieratus has been found to be polyphyletic with Aquila, meaning that while they have been grouped together, they do not share an immediate common ancestor, something that has to be looked into if this situation is to be cleared up. The biology and the anatomy of the Haast eagles is also something that throughout its time of understanding has gone through numerous revisions, and this will be the next segments to be discussed to tie in both their taxonomy and later on with their distribution and hunting methods. These eagles were quite the remarkable animals, weighing in at 10 to 15 kilograms in females and 9 to 12 in males, around 40 to 50% larger than other modern eagles like harpy and stellar sea eagles. The wings were interestingly quite broad and proportionally short for a bird of their size, leading to many theories on why this was, which will be discussed soon enough. Although at around 2.6 to 3 meters, their span was certainly not short when viewed at a first glance, and standing at up to 1.1 meters tall were quite the tall birds as well. When it comes to the wings and them being broad and relatively short, this for many years led to much discussion on whether or not these birds were even capable flyers in the first place. The large build of the birds led to the notion that they would have been poor flyers and that they would have had to spend much of their time on the ground, as stated by McCulloch 1982 and Milliner 1984, and some suggested they were on their way to it, Duff 1949. The bones themselves were noticed by Haast and Owen alike that they were indeed proportionally short, although neither of them doubted that they could fly well, and insisted that they would have been powerful and capable aerial predators. With time, however, the relative was either misquoted or forgotten, and many thought the owner was simply just short, a condition that if true would have implications for their flying ability. Proponents of the idea also noted the apparently long and thick leg bones, but despite this, the speculation had many flaws that would ultimately bring it down. Most apparent was that the wing reduction and leg hypertrophy was not supported based on references to specimens, as well as comparisons to a wide range of other birds of prey, and that many had not actually seen the material for themselves. Both of the authors stressed that they were describing and calling into attention the differing proportions and not the absolute length, and when actually going over the skeleton, it was found, compared to other birds, that they were indeed proportional in their size to allow for flight, when compared to the 3 major bones of other birds, and although they were approaching the upper limit of body mass for powered flight, were able to be just light and powerful enough to still do so. Another clue was that the sternum was fully developed with a robust keel which is both deeper and thicker than that of harpy eagles, given the increased muscle attachment required, which can also be seen in their pelvis where they would have attached. The expansion of the neural canal in the thoracic vertebrae of the shoulder, which in flightless or poorly flighted birds is much reduced, is also a point. And because of their proportionally short and broad wings, the reason as to why this is the case becomes evident when looking at other birds that occupy a similar niche, in particular forest eagles, which also possess broad wings for the purpose of increased speed and agility through dense foliage. Because of this, they would not be doing much in the way of soaring, and instead, selection pressure favoured individuals that could flap faster. Another factor that depends on wing length and to be more manoeuvrable through gaps, at the cost of higher rates of energy expenditure, having clear implications in their predation methods which will be talked about in the next section of this video. The pygostal is also large, indicating a broad tail like that of other forest eagles. Another benefit for mobility which has been estimated to have reached 50 centimeters in width, also increasing their lift force as well. Something also to note is their rather long and slender skulls, which were quite unlike the bulkier skulls of other eagles. The skull was 15 centimeters in total length, and interestingly lacking the tremendously deep beak as seen in Philippine and harpy eagles. The skull is actually quite superficially rather like that of an old-world vulture, and unlike the other aquiline eagles, the nostrils were partially closed off by ossification around its rostral, dorsal and ventral margins. Vultures possess such a feature in order to better stick their heads in while feeding within large carcasses and to prevent the airways from being clogged while they do so. And some have even suggested that they perhaps had the short head feathers or even bald heads of them as well, even though this is instead an adaptation for regulating heat loss due to their nature of soaring in areas where it can quickly become freezing, a factor that these birds didn't have to consider as they filled a different niche in their ecosystem. This indicates that they were immersing their beaks deep into the body cavity of their prey, whereas other eagles that typically feed on animals smaller than themselves instead pull on the exterior of a carcass to gain access to a smaller range of food. Haast eagles, due to feeding on animals larger than them, could therefore gain a massive amount of energy from just one prey item, able to reach into the anterior pelvic cavity with their beaks to reach the kidneys and kidney fat of moa, made evident by the damage to moa pelvis and their adaptations for pulling back. As they could not lift much of their range of prey due to their size, it meant that they could instead stand watch over it without having to fly off with it in the case of competition with other eagles or more powerful ground predators, which they didn't have to contend with, and given how large their prey could get, it wouldn't be going anywhere anytime soon. The legs and feet of the birds were themselves incredibly impressive structures and were powerful and robust. More so than any other eagle, with their claws being massive and strongly curved, with their external keratin sheaths giving them a length even larger than those of tigers, although they were proportionally shorter than those of harpy eagles, whose claws are especially long for their body size. What they lacked in relative length was more than made up for in robustness and the power that could be applied to the point. The greater the distance between the centre of rotation of the base of the claw and the attachment of the tendon, the greater the force that can be applied. What was found was that the grip strength of Haast eagles was incredibly powerful and could apply even greater forces than harpy eagles, which having a grip strength of around 530 psi, already enough to crush a human skull, the power exerted by these birds would have been even greater considering their size in comparison, allowing them to drive their talons through several centimetres of flesh, feathers and bone, causing massive damage to any prey item they came across, and exactly what they needed when contending with moa. Leading to this, the predation methods of the Haast eagle also underwent revision to find out how they killed their prey, or if they even killed at all. The perception of these birds as scavengers, and thus one that depended on the population dynamics of prey species, rather than exerting any evolutionary influence on their prey, has led to the importance of the birds being underestimated, with some considering that moa evolved in the absence of any predation, something also carried over to today in the case of living birds, but this, when compared to the actual physical evidence, does not hold up well. Although birds undoubtedly ate carrion when it was available, as were all predatory animals, there is strong direct and indirect evidence that they were indeed powerful predators. Obligate carrion feeders have notably different morphometrics than active predators because the functional requirements of the two ways of life are different. If these eagles were obligate scavengers, its body conformity would be expected to have been similar to that of living scavengers. Like many species of vulture, smaller weapons and reduction in those parts of the skeleton associated with a strong grip and killing ability would also support carrion feeding, which these eagles lack, instead possessing massive deep claws and robust legs, as well as a flight pattern more suited to flapping than soaring, as they could not spend long periods of time taking energy from the wind and thermals in search of prey, with high speed being essential for their wings to support their great weight. Birds have also been found in swamp deposits, leading some to believe they were scavenging on moa remains, although it is likely that many of them were simply deaths occurring over a period of time, without necessarily having to scavenge on a prey item to be preserved. Haast eagles would undoubtedly have eaten any carrion they could find, but as their prey was sparsely distributed and carcasses being harder to find in dense forest, it would not have been a regular enough food source for them to sustain themselves on. Many instances of damage on moa pelvis certainly imply this predation as mentioned earlier, although aspects of behaviour such as how the strike was made can usually only be inferred from living species closely related to the extinct animal being studied, and as was the case with these birds, it can be proven wrong. For the attack of large eagles on ratites, there is one observation of a wedge-tailed eagle attacking a young emu by grasping and holding the emu's neck, and from what would be assumed, Haast eagles would have been the same. Instead, there is grim evidence that they were aiming for a bigger target, that being a moa pelvis. A comparison of the relative size of the eagle's feet and moa pelvis found this to be quite evident, with eagle feet being quite able to damage much of their pelvis in the process. It was found that they used their talons to cause catastrophic damage to the bone in one sudden attack, causing a massive bleeding. Over a dozen individuals have been found to have suffered severe damage from eagle claws, including the largest of them all, the South Island's giant moa. The marks range from pinpricks to crushing indentations and punctures, with holes being up to 75mm deep and 10mm wide, all finding that they would have struck from the sides with their huge hind toe doing much of the damage. Several pelvis bear evidence of multiple strikes, as if they were altering their grip or making repeated grabs at the moa to inflict more damage. It was also found that much of the major damage was concentrated where the bone overlies the kidneys, and as mentioned, a key resource they could exploit, as well as branches of air sacs. Penetration of the subiliac space almost certainly resulted in a severe hemorrhage in the renal cavity, with damage to the vital abdominal air sacs, which would have led to many moa doubtlessly drowning in their own blood. To put such an impact into perspective, birds would have likely been able to dive at around 80 km per hour, and once impacting their unfortunate victim, it would be a force equivalent to a concrete block falling from the top of an 8-story building, more than enough to severely injure any large prey item, even those 20 times their weight. Haast initially speculated that the ecological role of these birds was that they hunted flocks of moa in the grasslands of Canterbury. This was the prevailing view, as the environment that Europeans first came across was thought of as the original, pristine environment of New Zealand, and the Haast eagles were thought of as an open environment predator. There was indeed a point during the last glaciation event where this would have been the case environment-wise, but it is now established that the natural Holocene of vegetation of New Zealand, even in the drier eastern areas, was forest or shrubland, something that was largely cleared by Maori after their arrival. From this, extrapolations can be made on the precise hunting plan these birds would have utilised. Birds would, like other forest eagles, find a suitable perch to scan for potential prey, preferably one where they could view prey from a considerable distance to build momentum for their attack, and then doing so with great speed and agility. The study mentioned earlier that stated they were adapted for open environments therefore hold less merit, and the biological discrepancies were now more than likely accounted for in life by powerful nerves and processing power, and their low sense of smell is common to predatory birds. Hence why many of New Zealand's flightless birds have strong odours easily detectable by dogs and other mammalian predators, but their cryptic coloration or nocturnal behaviour does imply an adaptation to avoid aerial predators, since there was little in the way of terrestrial predation. Related to this is the birds' distribution over time and where they lived and why, which has also been quite the interesting topic to figure out over time. Fossil sites containing eagle material is rare in high rainfall areas today, and therefore exhibit a similar pattern to that of their distribution of Pleistocene-age sites, although this was not because of poor preservation quality, as diverse fossil avifauna is indeed known of from many areas. And since eagle bones have been found in such terrain almost everywhere that suitable deposits exist, but not on the North Island and much of the west coast. It indicates that the distribution of their bones represents the former distribution of the birds, rather than preservation quality simply being better on the east coast. If the distribution of these birds was not directly correlated with a specific habitat, as they have been found in both shrubland mosaics, subalpine grassland and occasionally in rainforest, it must mean that it was instead the availability of prey like in other predatory birds that explains it, as this factor does impact breeding success in many raptors. While lower rainfall east of the main axial ranges meant that these forests lacked the multi-storey structure of the lowland forests of the west and north, the presence of many small-leaf shrubs and linears due to rivers frequently changing course and forming edge habitats alongside a greater soil diversity created by growth on these washed-out gravel riverbeds created a much more diverse and fertile area than the wet forests elsewhere, supporting more prey in turn. The three moa species they would have preferred therefore included stout-legged, upland and crested moa, with all of these animals preferring ecotonal or open habitats, with large populations and being more visible, although they would have definitely taken all the other species if given the chance. Large raptors also have large territories, typically 10 to 20 kilometers squared or more per pair, although dense concentrations have been known of in areas of particularly dense prey populations, as was the case with the New Zealand birds. Over the area of suitable habitats, which may have included up to 50% of just over 150,000 kilometers squared, the population of eagles therefore would have been around 3,800 to 7,600 breeding pairs, and with an allowance of 20% for young birds yet to claim a territory of their own, the population as of human arrival may have been about 15,000 individuals at most. When a Maori arrived in New Zealand sometime in the late 1200s, they were likely not considered much by them as they were already accustomed to preying on bipedal prey, and so the arrival of humans to the eagle was likely just a bizarre new form of their familiar quarry, a mistake all the easier made if a human was wearing a sealskin cloak or one made of feathers. Instead of being oblivious or in fear of these new arrivals, they instead may have seen humans as prey, and although there is no evidence for it, they would most definitely have been capable of it. It's from this that its reputation was likely formed amongst the Maori, which as we'll get into may give us some hints as to what they would have appeared like and how they affected people. The extinction of the birds has been found to be directly attributable to the over-exploitation of their preferred prey, the moa, as during the period of Maori arrival, the burning and mass hunting of these large birds caused them to decline heavily, which for the Haast eagles caused them to become rarer and with the lack of habitat, could not support their large energy costs. It has also been found that a bone owl used for piercing holes was made from an eagle bone, although at the time it was misidentified as a giant petrel. This bone means that Maori did utilise the eagles in some way, but whether or not they had killed this particular bird is unknown. Something that is most notable about these birds is that the experience of those that encountered them may well have survived into the modern day in some form. Maori oral tradition suggests that they would have been fearful of them, and that there were two names for two gigantic flying birds, which have been attributed to the Haast eagle, being Hokioi and Paukai, with the first being used in the north and Paukai in the south. The Paukai is described as a gigantic bird of prey which terrorised the local people, and with the name meaning old glutton, would regularly sweep down and carry off men, women and children to its eyrie on Mount Owen in North Canterbury. None could escape its talons, and the mighty rush of its wings struck fear into the hearts of all who heard it. One day, a visiting warrior heard the plight of the people and volunteered to rid them of the monster. Taking 50 armed men with him, he crept up to the foot of the mountain in the dead of night, and built a large trap out of manuka saplings. At first light, while the 50 warriors hid inside the trap, the warrior ventured forth to lure Paukai from its nest. The giant bird soon spotted him and then swooped down to devour him. Sprinting for his life, he just made it back to the trap before the bird could strike, and in that moment, the warriors sprang from their hiding place and speared the bird to death. Another tale, this time recollected from the North Island interestingly enough, states a bird known as the Hokioi, featuring the bird involving itself in a contest that took place between Kahu the hawk as to which could fly the highest, and in which the boastful Kahu was defeated. The Hokioi abided in the heavens or on lofty peaks, and that it never descended to the lowlands, but that it is occasionally heard far overhead in the dead of night crying its name, Hokioi, hu. This is interesting to note, as like the Paukai story from earlier, The birds were encountered or presumed to live in the high mountains and not in the lowlands, which could very well be the case of this being a passed down memory or experience of the last surviving birds, having been starved out through the loss of their prey and loss of habitat in the lowlands, and having to instead make do with the lesser resources at higher altitudes, which protected a great many birds for some time, although they would eventually perish. The loud cries and that the noted hokioi disappeared into the heavens with their powerful and loud wings is also fascinating, as this could instead be recollections of the now extinct South Island snipe, which although now being extinct does have relatives this can be inferred from. None could fail to hear the whirring of his wings as he returned to Earth, is very similar to what is known of in these small, unassuming birds which I have covered once before in an older video, in that they practice a night display which includes a deep roar created by the vibration of the tail feathers as the birds dive at great speeds, a sound which is most definitely quite frightening, and is also consistent with the strange noise at the dead of night descending to Earth. These stories may also give some insights into the colour of these birds, something widely sought after for those who want to reconstruct these recently extinct animals, with no suitable remains to prove anything conclusive, which has also been the case for even famous birds like dodo, which were, and still in many ways are, quite mysterious. This North Island tale is fascinating in this regard, and has this to say about what the hokioi was like. It was a very large hawk, its resting place was on the top of mountains. It did not rest on the plains. Its colour was red, black and white, tinged with yellow and green, and it had a bunch of red feathers on the top of its head, and almost as large as a moa. While these legends in some regards are vague, and this could easily be brushed off, what makes this more credible is the closest living relative of these birds, being the little eagle, does possess a white underbelly, black wingtips and edges, and does have red dorsal plumage, particularly on the head. From this, while it is not entirely conclusive, an appropriate reconstruction of these animals based on this would be something similar to these small raptors, a colour scheme that may have changed little when it came to adapting to the new conditions of New Zealand. The memory of these birds, however, would have quickly faded after their extinction, as after the extinction of moa in the South Island, the need to make a living in a depleted environment would have overshadowed these old memories, now being more focused on the sea than the land to survive. Human population declined in the south after the supply of moa and seals ran out, and South Island tribes were replaced by successive waves of northern invaders with their own traditions, perhaps explaining how the supposed recollection of these birds in the North Island came about, being through an absorption of culture, which once integrated was then passed down in these new arrivals and in their descendants. And these stories may just be some of mankind's last, faint recollections of one of the largest eagles to ever live. Birds also add even more in the way to do with cultural relevance, as they are regarded as the ancestor of ceremonial kites, vessels between the afterlife and the living world, and also in rock art, another fascinating instance of people recording what they saw of these great birds. Dramatic pieces of this type of art are found throughout the South Island, and the one at Craigmore Station is the one that is most well known and the most detailed. There is also some very compelling sightings to make mention of as well, which suggests that very small, remnant populations did manage to survive longer than the 1400s when they are typically said to be gone by. Haast, the describer of the eagle, may just have seen a living bird himself, when he and his survey party were sitting around their campfire in the headwaters of the Rakaia one evening when a large bird of prey crashed into the tent. Before anyone could reach for a gun, the bird then recovered its senses and flew away. The bird was larger and darker than the harrier with more pointed wings, which is where the story starts to be a little inconsistent with specimens, as they most certainly had broad, rounded wings, although this could have just been a spur-of-the-moment observation where Haast only caught a faint glimpse. The eagle's habitat by the time of this sighting in the 1860s was also much reduced, and many of the ground birds were also extinct, although exactly what this was still remains unknown. The last and most believable account was one recorded by Charles Douglas, a notable explorer who claimed in his journals to have not only encountered, but shot 2 large raptors in the Landsborough Valley, which he then proceeded to eat. The expanse of the wings measured 2.54 metres from tip to tip in the largest bird, and 2.06 in the other. Douglas's account is more credible than most, as he was a meticulous observer, did not seek publicity, and never claimed to have seen an extinct eagle, merely reporting on what he killed without giving a specific name to them. The report is also notable as it refers to an area and time when there were still populations of kakapo, kiwi, and perhaps takahe in this region, and little over a decade later, these birds would become much rarer and were soon to disappear with the introduction of mustelids. These wingspans are much greater than those of the living Australasian harrier, or the reconstructed span of the extinct Isles harrier, with the difference in size also being consistent with known measurements of male and female birds, although with no photographs or physical evidence. This account cannot be 100% confirmed. Whatever the case, Haast eagles were magnificent animals, and being the main top predator in a land of many unique birds, deserves its place as one of New Zealand's most notable animals. This video was especially enriched by the use of the book The Lost World of the Moa, made by Trevor Worthy and Richard Holdaway, was very important in reporting on all this information, and it was a truly valuable resource that I would highly recommend you read, as it also covers many other extinct and still living birds and their past. And with that, I thank you for watching this instalment of New Zealand Bird of the Week. For next time, you are now able to vote for the fern bird, well-camouflaged birds that are mainly found in dense, wetland vegetation. With that, I'll see you next time, whenever that may be.